Hello, my name is Larry Arnstein from Impinj. As you may be aware, many retailers, including Macy's, JCPenney, and Walmart, among many others, are starting to adopt RFID at the item level to improve store operations. Part of adoption of RFID at the item level for retail includes applying RFID tags at the source, and much of this work has to be done by the brand owners that supply products to the retailers. In this video today, we're going to be talking about the implications of applying RFID at the source, and one big piece of that is this notion of serialization. That is a new business process for brand owners. We will talk in detail about the implications of serialization, why it's necessary, and how it can be managed easily by brand owners. But first, let's talk a little bit about why these retailers are so excited about RFID. If you wanted to make sure, either a brand owner or a retailer wanted to make sure that the items that their customers want are on the shelf when they come into the store, one option is to do frequent cycle counting. But as we all know, frequent cycle counting with barcodes is slow and inefficient and also has a high rate of error. Not to mention the possibility of overcounts. Overcounts are particularly dangerous because they lead to what's called frozen out of stocks, meaning you think you have something on the shelf, but in fact there's nothing there, and you're not going to reorder more of an item that you think you already have on the shelf, leading to a continuous stream of out-of-stock events for shoppers. So we know that barcodes are not, taking inventory once a week or once a day with barcodes is not efficient and not really practical for retailers to do. However, along comes RFID, and it's a several orders of magnitude improvement in how fast you can take inventory and also how accurately it can be done. In this particular example, with several hundred pairs of jeans, we estimate that a barcode count of this wall would take up to 2 hours, whereas it can be done in about 2 minutes with RFID with a lot less error and no possibility of overcounting. So we see the big and of course the baseline benefit for our retailers is that they have better on-shelf availability, but there's also lots of other opportunities to build business value on RFID, including improved loss prevention, improved customer experience, and many other things. So the question then becomes, what is it about RFID that makes this possible, and why does that create a serialization requirement where none was there before? So first of all, as you all know, with UPC coding, if I have 3 pairs of jeans of the same size, the same color, and the same style, they're going to carry the same barcode, which is the UPC identifier for that item. Now, with barcoding, the burden is really on the operator of the barcode scanner to ensure that they scan each and every item exactly once. That's how you get accurate counts with barcodes, and it requires the operator to individually identify and find each tag and scan it once. RFID shifts the burden from accurate counting from the operator to the technology. And the way that's done is by ensuring that each tag has a unique number rather than the same number. And in this case, we're depicting that the unique number is a combination of the UPC plus a serial number that uniquely identifies that individual item. One of the misconceptions about serialization for RFID is that it's done to provide what you might call life cycle traceability of each individual item throughout its life cycle through the supply chain. That's not really the main reason. The main reason for tagging apparel items with serial numbers is to make sure we get accurate counts. And what we're showing here is a handheld reader. When you turn that handheld reader on, it starts reading tags as fast as it can. And in fact, it will read the items more than once. The only way you can ensure that you get an accurate count when you're reading items potentially more than once is to make sure each item has a unique identifier. And we're sort of showing that the reader scans item 1, 2, then 3, and then it goes back and scans item 1 and 2 again. And the serialization allows us to know that that's in fact 3 items and not 5. So that's why serialization is necessary in RFID. In an RFID tag, and we'll talk a little bit about what is serialization and how it's managed. So let's go ahead to the next slide and talk about what serialization really is in the RFID world. And then the big topic that we're going to talk about is how can brand owners efficiently manage serialization so that it's not disruptive and not expensive for them to participate in these retailer-driven RFID tagging programs. So serialization is really just the process of taking that UPC identifier, which is sometimes called a GTIN, a standard general trade item identifier, and combining that with a serial number, a unique serial number, and we're going to talk about where that serial number comes from in a bit, to produce something that's called an EPC, or an electronic product code. That electronic product code, or serialized GTIN, is encoded or written into the memory of a tag that goes onto each item. That tag includes really two elements. One is a little antenna that's embedded in the tag, and then a tiny chip from Impinj called a Monza RFID chip that actually stores this serial number, this SG10. The encoding process is there's two big terminology that we're using here. One is serialization, which is the management of serial numbers to enable us to have unique numbers for each item, and then the encoding process, which is actually putting those unique numbers into the tags that go onto the items. So instead of, in the end, having three indistinguishable items on the shelf, we have three items that may be the same style, size, and color, but each have a unique identifier so that we can have accurate counts. And those identifiers are stored in individual chips in each of those tags. So that's serialization for electronic product codes, or RFID. And now we're going to talk about the options for how you manage serialization in your source tagging operations. So there's really two big ways of going about this. One is what we're calling IT-based serialization, where you think of the serialization problem as basically an IT challenge, where you have to have a database somewhere or a system for managing serial numbers. You're going to distribute those serial numbers out to where they're applied, combined with the UPC data and written into the tag. You're going to distribute those numbers to your operations, perhaps in manufacturing or in distribution centers, where that encoding process takes place. And the other option is chip-based serialization, where there's a technique where the serial number actually comes from the chip that's already there. And we're going to talk about that as an alternative to the IT-based approach. Within IT-based serialization, there's really two approaches. One is to do it yourself, and the other one is to outsource it to a service bureau. In either case, what's happening is, at the point of use or a point of application, you're combining a number from an IT system with the UPC to produce the EPC and then encode that into the tag. And we're going to talk about how this picture is different with chip-based serialization after we're finished talking through the IT option and looking at the strengths and weaknesses of that approach. So this picture really captures what happens in an IT-based serialization approach. I have a UPC that gets distributed to all my points of use, maybe to my manufacturing plants or my distribution centers where the tags are applied, printed and applied. Those could be done in service bureaus, they could be done in factories. And so one of the nice things about simple UPC tagging is that it can be done in parallel, and you don't have to have any coordination or memory or history. So for example, if I have two locations in the world where I make the same exact item, the same G10, the same SKU, I can distribute that UPC number to those two locations. They can make those tags. There's no coordination needed. They can run in parallel. And everybody in the apparel industry today has good variable data management procedures and business processes for getting that information out to the points of use. When we add serialization, somehow we need to keep track of the serial numbers that we've already used, and there's really two kinds of coordination that take place. The first one is if I have two locations that are distributed around the world globally working on producing the same product, I need to make sure that location number one is using different serial numbers than location number two. So that requires real-time coordination of some kind. Furthermore, if I make the same product this year and then I go back next year to make that product again, I need to remember which numbers I used so that I don't use them again. So I have both coordination in real time as well as memory and history that are required to implement a serial number management system. And finally, I need to have devices distributed throughout the world that can actually do the encoding. I need to have software that knows how to combine those serial numbers with the UPC data to produce, at this point of use, to produce an EPC. So these are some of the challenges associated with adding serialization to your existing manufacturing process that go along with an IT-based serialization solution. Within IT-based options, there's really two major approaches to take. One is what some people refer to as a dynamic model, where I've got a cloud service, let's say, that kind of coughs up or distributes small blocks of serial numbers on demand each time a particular location needs to produce a set of tags. So let's say I need to produce 100 tags for a lot that I'm manufacturing in a certain location. That location will contact the database, the server in the cloud, and say, please give me 100 numbers. You get those 100 numbers and apply them to tags, and then you're good to go. The problem of coordination and memory is all centralized in this server that and it's very flexible because now I can turn locations on and off. I can have lots of parallel activity. The problem is that from an implementation standpoint, it's quite sophisticated. I need to have all kinds of nice seamless connections between my points of use and my central server. I need to have devices that know how to contact that server. I'm dependent on a global internet connectivity at all times. So it's very sophisticated, and as a consequence, I also get a lot of flexibility out of it. And those are some of the strengths and weaknesses of the dynamic approach. Another alternative that's quite popular is what you might call a static approach, where I already know that I'm going to have, let's say, 6 locations that are going to produce my products. So I'm going to allocate large blocks of numbers to each of those 6 locations. It might be good for several years. And then I can let those locations go and do their thing, and I don't need to coordinate in real time. And it's kind of up to them to manage the numbers that they're using within the space that they've been allocated. The problem with the static approach is that the simplicity also reduces the flexibility, and it can be fragile. So for example, what happens when I add a 7th location? Or I stop using one of those locations and bring on another? How do I transfer those blocks from one place to another and ensure that I don't have duplication? And so there's definitely a trade-off to be made here between the dynamic and static approach. And there's different extreme implementations of both of these. There can be combinations or hybrid models that work as well. And of course, one option for implementing this IT-based solutions, either dynamic or static, is to do it yourself. If I have, let's say, a couple of manufacturing sites and I want to do a static approach, I might have a spreadsheet that I assign someone in my company to manage those blocks. It becomes sort of a business process that doesn't really require a lot of software, and someone in my company is responsible for making sure that we don't reuse numbers and allocate it. So that could be a very simple kind of do-it-yourself approach for a small brand owner. Now, the other big option, counter to the do-it-yourself model, let's say I'm a really big brand owner, I've got 30 or 40 or 50 sites that manufacture. Those sites are changing all the time. I don't really want to invent a system for managing these serial numbers, so I'm going to outsource that to a service bureau. The service bureaus have already invested in the IT technology, or are investing in the IT technology to manage that data and to kind of implement this global network. And so instead of having the brand owner be responsible for producing those EPCs and then writing them into the tag chips, it's the service bureau that does that. And you're really building on your existing variable data management process that may already involve those service bureaus. So what happens is the service bureau gets some kind of EDA or EDI data from the brand owner. There's an order. The service bureau makes sure that the right number of tags are printed in the right locations at print shops, either co-located with the manufacturer or separate buildings, and those tags are shipped or delivered to the point where they're applied. And it kind of feels like your existing process, except that you're having your service bureau also manage the serial numbers for you. One of the challenges is, what if you need to use more than one service bureau for your global operations? You're kind of now at an extreme form of the static model, where I'm going to assign maybe service bureau number 1 a big block of numbers that they're allowed to use for my business. I'm going to assign another block of numbers to service bureau number 2 that they're allowed to use. And so I've got, again, that employee of the employee of the brand owner managing these static assignments for various service bureaus, and then the service bureau is doing all the heavy lifting for the detailed serial number management in the global print shop operations. So again, you have an option to go this route, and it can be very simple for you as a brand owner, but there may be a cost associated with having your service bureau do that work for you. So the alternative to IT-based serialization, and one thing I want to mention before we get into this, is that all of these options that we're talking about are all legitimate. They're all very effective, and I can point to brand owners that are doing all of the above. So again, it's a matter of looking at these options and choosing the one that's right for you. Chip-based serialization is something that some large manufacturers, brand owners, are becoming very interested in and are starting to deploy. And the reasons are that instead of getting, the main reason for this is that instead of getting the serial number from this IT system, which we've already talked about can be either complex or inflexible, it doesn't come from the IT system. Rather, it comes from the chip. Now, a Monza chip from Impinj that lives inside of the tag, the RFID tag, has 2 places to store data. One is what we call a read-only memory location, and that's something that's called the tag identifier, or the TID. That tag identifier is a serial number that's written by Impinj at the point of when we manufacture the chip and can never be written again anywhere else in the supply chain. The idea of chip-based serialization is to use the serial number that's already on the chip as the source for constructing your final EPC that's written back into the EPC memory of the chip. So it's kind of from the chip and back to the chip. So we get the UPC that might be part of the visible information on the tag. We combine that with the serial number from the chip to produce an EPC, and that EPC is written or encoded back into the EPC memory of the chip, so that when the retailer user or the brand owner reads that tag, they get an EPC that includes they get an ISGTIN that's based on the serial number that's in the chip, but comes from the normal EPC memory location in the tag. And you can see that this round trip from the tag to the tag means that we implement that under the hood, meaning that from the outside world, it looks like you're sending a barcode down to a printer driver. And when I say under the hood, what I mean is under the hood of, say, a printing and coding device, maybe from a company like Zebra or Avery or somebody like that. Okay, so the idea being that you send a barcode through your normal printer driver to the printer. The printer reads the serial number that's from the chip, combines it with the barcode data, and writes that back to the tag all within the printer. So if I were to draw a picture of what that like, it looks a lot like your normal business process today. I take my same old printer driver, I send a barcode information down to the printer, I have a roll of tags that might be adhesive labels that are being printed by that printer that also contain an RFID chip and an RFID, what's called inlay inside of them. And you can even, if you look closely, see that this paper-faced adhesive label actually has an inlay inside, an RFID, Monza-powered inlay inside. And the printer encoder does all the serialization for you. It happens under the hood. And what comes out is a tag that you can apply to the item, and that item becomes a serialized apparel item with an RFID tag. So you can see how this kind of fits and looks like your existing business process potentially for producing non-RFID tags. And it basically says all that serialization is going to be done essentially by the chip manufacturer, and then the brand owner gets to leverage that work that's already being done. One of the neat things about chip-based serialization is that it is not tied to printing and encoding. You may, for example, already have a large infrastructure of printers installed, and you're thinking, gosh, do I really need to replace all of my printers because they don't support RFID? Or you might say, you know what, we can run these RFID tags through our printers but not encode them, and once they're encoded, once they're already attached to the items and placed into a box, I can run them through a bulk encoding process that does all that, reads the TIDs from the tags, combines them with the UPC data, and writes them back to the chip right through the box, because I don't need to have a visible line of sight to the tag. That's one of the neat things about RFID. And all these methods that are working on more than one item at a time that don't involve printing, we're calling bulk encoding. Another option is that if you do want to do, let's say, encode before you apply to the tags, printing is clearly one option for that, but there's other forms of what we're calling inline encoding that can also work. You might have automated label applicators that can be outfitted with RFID, that as those labels are applied to the items, we're doing the encoding even after they've already been printed. So we can separate printing from encoding if we wanted to do something like this. Or your service bureau might make an investment in very high performance inline encoding and printing that you do it on a sophisticated line, and with those customers we can work closely with the service bureaus to implement chip-based serialization in a very high performance line. In this model, it's kind of a hybrid. You're still going to the service bureau for the tags, but you're not relying on the service bureau for managing the serial numbers for you. That's kind of neat because it allows you to work with multiple service bureaus in different parts of the world and not have to have any coordination. As long as they're all doing chip-based serialization, that model will work fine, and they can run in parallel just like your current business process allows you to do. So those are some of the options that are available for deployment, all of which are being experimented with and deployed at various stages today. So as a summary, one of the two advantages of chip-based serialization is that the serial number that you need to combine with this UPC is already part of the chip. And what happens is distribution of those, physical distribution of these tags to your points of use or points of application is how you distribute serial numbers. You don't need an IT system to do it. It's non-disruptive in the sense that your existing business process for variable data management still applies. You have to get those UPC data and other information that goes on the tag, country of origin, material content, that kind of stuff, needs to be distributed out to those points of use, just like you're doing today. We have inline methods and bulk methods that we've already talked about that allow you a great deal of flexibility in how you choose and how and where you choose to do the encoding that may or may not be at the same point where you're actually printing the tag. And one of the advantages of bulk encoding in particular is that the tag does not even have to be a conventional adhesive label. It could be a hang tag, it could be a sewn-in label, it could be any kind of tag. It doesn't really have to necessarily go through a printing machine to get encoded. To learn more, come to our website at impinj.com/apparel. You'll be able to find a white paper describing chip-based serialization along with other resources. Impinj is the leading supplier of tag chips, reader chips, and high-performance reader systems. It's been my pleasure to speak with you today, and I hope you'll give us a call if you have any questions.